Why don't we find where this function here is discontinuous? This function is called a rational function, right? Because it is a quotient of two polynomials. And there is a little theorem that says a rational function is continuous wherever the denominator is not zero. Why don't I just write that down quickly? That a rational function, and a rational function is the quotient of two polynomials. Certainly the x and x squared minus 20 plus x are polynomials. A rational function is, well, how about we say it like this? A rational function is discontinuous at exactly the values of x which make the denominator zero. So really all I have to do is find out which numbers make the denominator zero, right? So let's solve x squared minus 20 plus x equals 0. This is kind of written in a weird way. We should, it kind of looks nicer to have the polynomial written so that its powers are decreasing and in order. How do we solve this? Well, whenever you have a quadratic equation, you could use quadratic formula, but sometimes you can factor, and that's often quicker. Do you remember how that goes? We want to find two numbers which have a sum of positive 1 and a product of this number times this number. 1 times negative 20 is negative 20. So we kind of have to think about that little problem there. We want to find two numbers which have a sum of 1 and a product of negative 20. Well, think about numbers that multiply to negative 20. Could you make that add up to 1 somehow? I think we can take 5 and negative 4, right? 5 times negative 4 is negative 20, and 5 plus negative 4 is positive 1. So that actually means your answer is x minus 5 times x plus 4, excuse me, x plus 5, x minus 4 equals 0. If you want like a longer way to see that, you can use what's called grouping. You know, since these numbers add up to 1, this middle term, I can break it up with my two numbers here. I can write plus 5x minus 4x minus 20 equals 0. I could have written them in the either order as well. It doesn't matter. Look at these two separately here. Over here, I can factor out an x. Here, I can factor out a minus 4. And notice I have x plus 5 common into both of those. So that means I can factor that to the front now. And I get what I had before there. Okay, so I don't want to waste too much time talking about factoring. Now, why is it nice to have this factored? Because if two things multiply to 0, that means either this one is 0 or the second factor is 0. And then I solve each of these individually. So here x is negative 5. And here x is negative 4. Oh, I made a mistake here. I apologize. This is x minus 4, right? So I need to put a minus there. And so when I solve this, my answer is x is positive 4. So that's good. We have those are the two values where this function is discontinuous. Why don't I just show good style and write a little sentence here? The function is discontinuous only at x equals negative 5 and x equals 4. And those are all the values where it's discontinuous. So just remember, whenever you have a rational function, that function is going to be continuous at all numbers except the bad numbers. And the bad numbers are those numbers which make the denominator 0. In this case, the bad numbers were negative 5 and 4. And therefore, the function is discontinuous at those two values. But every other number, the function is continuous there.